nice to know all the shortcut keys and stuff like that, but it crashes all the time. The emulators don't work. The debugger doesn't work. It's just a mess. And then, yeah, so
It's only for Android.
no, it's not. Jonathan can call. Yeah.
I know I currently like using Visual Studio. For me personally, I actually found it to be very productive to use the JetBrains Writer IDE. Going from Xcode, it actually just does compile pretty quickly. Just give you a lot of cool shortcuts. And even will format the code for you. If you're doing something that can be easily rewritten, something that's quicker, like autocomplete for you, which gets to be. I think we actually have the stats for this. Give you stats like how often you use shortcuts, and I was doing that like all the time. So I'm like, I don't know what I'm doing. I'll send it for you, and it's cool. But yeah, we didn't have any sort of similar issues. The only thing that was a little weird is when you're trying to debug breakpoints, it won't allow you to print out individual objects like you do in Xcode. You have to sort of give a list of like the objects that are there. You kind of have to go through each of them. Yeah.
Yeah, we'll have a separate site for iOS, and the ID is highlighted there as well.
I think when you consider the IDE, you have to consider how good Android is for the most part, how much better it is than Xcode, and so it's just a significant downgrade for Android developer. What are you gonna do? That's the truth. So anyway, so then I'm going from the bottom up, I guess, because the top one is kind of like, I don't know. If you guys know Android development, you know that it's really heavily dependent on third-party dependencies. For example, in every app we have to use image handling dependency. Picasso or Glide. Every app we use ArchJava. We didn't have Arcs in that app. Every app we use Dagger for dependency injection. We didn't have access to really any of that. We had Picasso, we had calligraphy, which are really the bare minimum. I had to learn a new dependency injection framework for this app, which took like an extra week of my time. It's just what happens is the third-party dependencies are taken from Java, run through a C# generator, and then put on GitHub and never maintained. So we need calligraphy and Picasso, but they're never ever maintained. They were just generated like once, like a couple months ago, or a year ago, or 2 years ago. So oftentimes they don't work right, or they're just weird. So if you guys know Android development, it's really heavily dependent on third-party libraries, and not having access to up-to-date versions of those libraries was a huge issue. It continues to be an issue as I'm still working on something related to that. It's just a huge chain. I just don't really understand why it's so hard to maintain the libraries, but it really is. And then, so to add together the IDE and the debugger not working as well, the third-party library is not being maintained, the C# layer on top of a Java layer, it becomes like a huge mess. If you were to just have one of these issues, you could say, okay, I mean, it's just an issue, that's a program issue. And you have 4 or 5 issues, and they're just stacked on top of each other, and you don't know which one's causing it, or maybe you have to shut your computer off for 5 minutes. The build time takes longer. It just ends up with a really slow development duration, like really slow. I don't know if you guys know as well, Android has something called Interrun, which some of us use, some of us don't. We don't have access to that at all. So every time you do a layout change, you have to wait a minute and a half to see what the change is. So oftentimes you just see me kind of just staring at the wall, waiting for a minute and a half to change margin, or to just change a button. That's just a complete waste of my time, to be honest. And a complete waste of Lyft's time and money. I just don't really see a future for this unless we can dedicate someone to actually learning and being like a full-time Xamarin engineer. It's just really difficult for Lyft to actually give the time to that, but maybe they will. And so yeah, at the bottom, as you can see, there's just too many layers and a lot of stuff going wrong all the time. I think one example is, yes, 2 days ago, I think Kung Lei had to, or I had spent an entire day trying to figure out why we weren't building it. He's built. Kung Lei found the answer. Thank God for Kung Lei. He's so smart. If not, I would have lost a couple of days, just figuring out why you can't build a release build. And that happened throughout the process. Like, an issue would kill a day, 2 days, 3 days, 4 days, and then we add up this crazy timeline. It just became such a huge issue. Yeah, I think if you're going to get anything from this, native code is probably better, but there could be a solution that Xamarin would be good for, but I think you're gonna need more time, more. I just don't really know. But yeah, I think that's it for me. So, sorry about that. All right, Joe. What's the question? Okay, so what happened? I guess I forgot into history. I think project was really fast in its conception here, much faster than a normal project. And so the only thing that I really knew in Xamarin Code was this guy here. And I kind of recruited Sheen to do it, but he didn't really want to do it. And so no one really knew anything about what was going to happen with Android before the project started. And at the beginning, it was really like, okay, this is cool. Alex is doing a lot of shared code for me, and just figure stuff out. But as the project went on, it was like, all right, this is a problem, this is a problem, this is a problem, this is a problem. 5, 6 problems deep. We didn't know. We had no idea. So it would have been nice to have like a month to figure it out, but we just didn't have that. And I think Alex is going to talk about how the timeline really affected us. When he talks. Yeah. Go ahead. Yeah, so, what happened was at the beginning of the project, they suggested us to learn how to, do that. I just don't have time. I spent a week to figure out how to, or have someone figure out how to run Java code through a generator and figure out this is code that actually work. Put in a dependency, and put in a new dependency, put that dependency in the app. It just takes time. I just didn't have time. And so, if we were to do this again, I would 100% recommend someone learning how to do that. Running Java code to a generator. Yeah. Thanks.
Thanks. That was positive. Yeah, surprisingly, we didn't, to Joe's question, we didn't know how bad it's going to be on Android. We had 2 weeks for technical discovery, but we were just 2 of us. That machine was not around at the time. So all the problems that we encountered, we saw later. And also, iOS is very, very different from this experience. So I'm going to talk about iOS. So, of course, it works. It works like iOS. So you don't need to actually learn anything. Learning is super easy. I started writing C# code with the code challenge with no actual preparation for that. John joined the project and started immediately delivering stories, which was super impressive. Whoa. Okay. So one more for iOS again. I think though when Medina joined, he didn't have much problems with C# as well and Android. So for me, IDE is great. We have 2 options. Visual Studio is more stable, more reliable, and Writer is way better than Code in terms of productivity that John already talked about. It's haven't crashed on me, but then again, I rarely use emulator and Android code. For me, another positive thing is that we didn't have to use Cocopods, so we didn't have any issues with that at all. Dependency management in Xamarin is just use for packages and that's it. It's just super simple. You don't need to worry about that at all. And most important part is we never had performance issues. This is something that we're ready to do in terms of really to bump into when we were writing the project because we knew that it's going to be a high quality app, and we need to make sure that Xamarin can deliver 100% native performance. And the good point is, yes, it can. So bad things, storyboards on iOS with Xamarin suck. You need to open the same way that Android. You need to open the storyboard in the actual Xcode, and then the outlet generation is weird. And I just started playing with it, and I decided, I'm going to go with the programmatic constraints, and it actually played out very well, except for we have 34% of shared code instead of 44, so Zach was actually right. It's about 10%. For iOS, I think C# is, I like C# a lot. I love this language, but it's not as good as Swift because it has null pointer exceptions. It's not safe. It's not as safe as Swift or Kotlin. So, and it also doesn't have associated values in switch statements. So that's pretty bad. But it has a lot of positive things now about it in the next slide. Another thing is we have less third-party options. Although I didn't have a problem with that. We have the major libraries that we use is like web image loading as the web image, some tools that we do every day. They are either there, floating point table, for example, floating text or whatever. We have them, or you can just translate them because they're very small. Just write them in C# and it's going to work. And the final, which is probably the most tool for me, is the memory leaks, because we kind of forget about them in iOS with Swift, with all these weak variables. Here it's a mess. You need to constantly control what do you do with, like, you need to watch out for memory because there's a lot of blocks, a lot of closures. The syntaxes, lambda functions are super tricky in the part. You can have a lot of references, plus you are dealing with two memory management systems, one from C# garbage collector and automatic reference counting from iOS. So we had kind of a lot of issues with videos, releasing videos from the AV video player and stuff like that. The delta, however, is that Alex is going to do that again. So for me, the experience was maybe not too much worse than actual native development. But again, this is iOS, and maybe it's something that Android is lacking in the framework, or iOS is gaining some more. Maybe just they spend more time on working with Android. But yeah, for us, for me, it's a very different experience. I didn't have any problems that Zach was struggling with. Well, some problems, but definitely not as much. So I consider myself lucky. But that's why I was writing more code than that. So, go ahead. Well, I can quickly show you the dependencies from iOS. So I have a floating label, another floating point label, hotkey, empirical, settings. Setting is a plugin that allows you to share NS user defaults and the keychain with Android from shared code, and as the web image. So not too much. Some of them I don't remember exactly which one I just rewrote because it was just like one file. So I just wrote it in C# and it just worked. So yeah, it's definitely not ideal. Also, when we were talking about Microsoft at the beginning of the project, they offered their assistance if you don't have some libraries or that, just connect to us and we'll try to figure it out. But again, because of the timeline, and this is a huge implication, you had like more time to deal with these things. It would be better, but since we are like need to do the project because it's insane timeline, and then also dealing with this library or talking to Microsoft is, well, it's hard, like give you pressure so you don't manage your time very well in the most efficient way. Also, leadership. Whoa. Yeah. Did you have an adapter? Sorry. Well, maybe I'll try Russian. So Sharp, nice language, robust, very pleasant to write in. There's a lot of, it's very mature. It's 20 years old. It's tested, over-tested. It's very convenient. It's pleasant to write, especially in Writer. It's very simple to learn. It's basically the same thing as Swift, same exact thing as Java. That has a huge C# community. Yeah, Android, it's good call. Xamarin doesn't have a big community, so if you want to deal with some issue, you need to go and see how you deal with it in C or Swift, and then go and write it in C#. But if you want to write something in shared code in C#, some cool stuff with this, manipulations, parsing, it's all there. It's no problem at all. IDE is awesome for iOS again. It's just you need to understand also this first iteration. For 2 months, we were working with Writer when it was still in beta, so it wasn't even the released version. And Microsoft, for Visual Studio, Microsoft always does horrible apps for Macs, so it's not a big deal. Not surprised. And also, C# can be used for backends, so it's definitely a good tool in your toolchain if you want to learn that. Thank you, JD. Works. Bad things again, null pointer exceptions, and the damn semicolons, and that's just frustrating. It's 20% human. Yet, awesome language worth learning. So if you invest in it, you will definitely not regret. IDs again. Just I'll quickly reiterate it. You have 2 IDs for the options. There will definitely be more. Definitely be better in the future. Microsoft releases updates every week for Visual Studio fixes and stuff like that. Writer is going to be incrementing the productivity as well. Issues is both have problem with bugger, and both are not exactly the most stable. They're less stable than native, and again, Writer is way worse than Android Studio for Android. Way worse, but it's way better than Xcode. So trade-offs everywhere. Good enough. This is a delta. Quick about it. Architecture is super confusing. Let me try to explain it. So in the bottom of it, we use first of all MVVM. Very simple, very robust. For this project, it's kind of something that Xamarin recommends doing in the first place. So in the bottom line, we have controllers and activities in Android. Sorry. When something happens, when you tap a button or you make an API call, you produce an action. Like you call an action on the view model. You call a function on the view model. But you never get back the result. If you make an API call, you never get back object that is returned. Instead, view model changes internal state, which watches all the data, saves all the data in it, and the state change triggers the function in the activity or controller, which is really called on-state change. And from it, you again ask for displays from the view model. So it's like maybe one way, kind of unidirectional flow, data flow, whatever. The good part about it is it's very easy to follow, and it's very don't need to say, hey, you should put this code in this part of the app, or you should put this in the view model. Once you set up a couple of controllers or activities, it's very easy to continue working, and it's consistent. You don't need to spend too much time on code review for that. It's also very understandable. All the state is encapsulated in one place, in one function, so you know if something changes at all, this is where the action is happening instead of running through the functions and in the controllers. Also, separate logic for this view model is a great thing because by default you're sharing to Android. So the good part is to extract logic. It's unit testable. Controllers are super simple. The most complex controller we have is 350 domains, and this is the one that manages 14 states. So that's very cool. Very quick to develop. No law in architecture. That's good from John. That was pleasant to hear. And another great thing, as I said, it encapsulates possible states. So once you open the screen, once you open the code from the controller, you understand what kind of happened here, and how do you handle errors and stuff like that. A bad thing about it is it's the most simple solution, so it definitely can be optimized, which we didn't really have time to do. So great baseline to build on top of. I also want to show a couple of I know it's not architecture, but it's cool things that we made in the beginning. So first is routing navigation. This is a huge enum. It encapsulates every single screen that we have in an app. So it's like a map. You know what features you have. You know where the destination is very easy to find. You need to remember names of the controllers and like decode it. And somehow when you join the project, this is, you know what it is. Like you remember jumping in a legacy project or something like that. Just like, where is the feature that I need to work on right now? This kind of gives you a good understanding. It also decouples controllers and activities from each other in view models. So this code, it lives in the view model. You say router navigate to focus selection, you pass presenter, here gives the arguments, and you pass navigation type model or push. Very simple, easy to read, very easy to modify. And this gives you basically deep linking and if you need to like integrate branch for free, and it's super easy to set up. Of course, you'll say that this is going to be a huge switch statements, which we already discussed. But this whole thing is the only switch case is encapsulated in the control factory when you do the dependency injection. So it's buried deep into the code. You never modify it. You modify it only if you add destinations, but then you just reroute and create a new controller for the destination. That's it. Very simple. Yeah. Another thing is the networking. So these cool guys are the endpoints. We create every endpoint is an object, which consists of the URL, the endpoint URL, the method, the payload, and be any anonymous objects. If you're familiar with JavaScript or something like that, you literally just create anonymous objects and pin them down to the endpoint. And like URL can be like that, for example, when you need to specify your source key. So the URL knows about the endpoints in creates endpoints for specific calls, loads the payload, and then gives it back to the remote resource. And any questions so far? No? Yes, of course. Networking, so when the endpoint is created, it is passed to this function. It's like a single public function in the networking, or we call it remote resource. It's generic asynchronous tasks that just takes, you specify the object of return and pass endpoint. And this is on a high level how it interacts. So we had unfortunately a huge issue with importing a third-party dependency for networking. It just broke the build, and we couldn't like fix it for a long time. That's why Chicken quit. And that's not even a joke. So yeah, we just took the regular cheap client that's provided by Microsoft and created this little thing, which is pretty well. We just created a request response. When it's returning, we check the status code and then serialize object. Status check status code from response message, also the exception of concrete error codes. I will talk about concrete exceptions in the next slide. Yeah, so exceptions. This is a standard thing for Java, for development, but in iOS we don't do that at all. And I think this is something that we can learn from Xamarin and Android, because every time we create some sort of networking error, for example, or you bump into an error, even in the logic, you create a specific exception. For example, this is a premium feature. So before giving access to the user, we need to check if user is subscribed or not. So we handle this like no subscription. You just no subscription stage. you bump into resource not found, this is an empty state. If you bump into await an approval exception, which means that you ask your parents to buy your subscription and parents don't want to do that, so this is a specific case that we deal with in a different way. And this is a generic thing, just to explain an error. This is what we do in iOS development, last statement. This gives you a structure, and also when you read this function, you kind of understand what can go wrong, and you can see the edge cases and plan for it. And when you develop, also this kind of becomes the your attitude towards how do you handle exceptions, how do you handle errors in your state. You're like, okay, this is what can happen here, starting from different status code. This is how I react. Every one of them. Really fast. So this is the thing that I had, honestly, a roller coaster with Xamarin myself. It's especially when I see how Zach struggled with it. It's just why you want to drag your team through it. It's just insane. But there is a trade-off, and this is pretty big in my opinion. 34% shared in iOS, and we weren't even trying. It was just like, yeah, just put view models in the shared code. It's like the dumb thing you can do, and you get 34% free. And then 44 for Android, but without XML. And to the end of the project, we were in this very cool position, and I really enjoyed it for the last 2 weeks when Zach is fixing a feature, 7-day feedback, and I have the story waiting for me. And I know that I may delay this for the sprint, then that delivers it, and it's done for me. So I just deliver the story and get the 3 points. Same goes with bugs. Now we do a lot of polish. Everything that all the bugs, not all bugs, but bugs, like 15 to 80% are in the logic. So if you fix once, it works for both forms. This is very exciting. This kind of buys off now after we deliver, by the way, we submitted today for iOS to the Apple Store. Last night, the final build for V1, and now we see the UI is built, it's only polished, and then working on the logic and extending functionality. It's going to be a way faster to iterate on a project because of that shared code. So yeah, we definitely threw ourselves on the barricade first and suffered a lot with this all inconsistencies and dependencies and stuff like that. But when we are able to deal with these issues, which just requires some time from engineers to kind of solve this problem. It's not something that cannot be solved. It's just a problem that we need to attack, solve, and then use the product of the result of it. And this is what we shared for the whole project. The system lives in view models, so you never controllers or activities rarely know about what an alert is in general and how to handle errors. Everything's happening in the view model, and you don't typically worry about it on the front end. On the front end code, we shared analytics. Spent 2 weeks on analytics, but for one platform only, and it works on the second one automatically, almost automatically. We shared models, obviously, view models, obviously, networking. It's kind of like an obvious thing to do, but it's a huge deal because you set it up once and other platforms doesn't care. You have all the endpoints, you're never mistaken what you're passing. You never need to figure out how to parse this or that. Output of the endpoint is done once, and this saves a lot of time. Routing as well. All the navigation, again, is handled by the models. So when you start implementing deep linking, everything complete, together with mounting the way we set it up, it's just, you have it already. Parsing for HTML and text, session management, settings, as in user default settings, all displays for all views in the app, not all, majority. Error handling, user flow. You have a rule. If you have onboarded, this is where you should go. If you are not subscribed, this is where you should go. If you're subscribed, what happens when the user tests on something? Everything's handled in shared logic, so you never have logical bugs that exist only on one platform. they only exist two platforms. It's easy to fix, and it's fixing for both at the same time. Plus some exceptions and balances. We did not, however, share localization files, and this is a big issue because native code, native layouts uses native localization, and then the view model sometimes uses constant files, and sometimes it just plain in English. At some point, we just gave up to fix this, and just we have a couple of features that are only English in view models. That sucks, but trade-offs everywhere. So Delta overall, we delivered on time. We delivered in time because we had more resources than we originally planned for. So, but also we were at the risk of not delivering on time because of the poor management of the staff timeline, which was my fault, and not the problem of technology itself. We are able to deliver relative quality app. It looks good. It works great. It scratches, of course, it's V1. And it's C#, it's not Swift, but it's not horrible at all. Share code is amazing. It's great. Like literally, it's very rewarding when you understand that you built a system and now you can benefit in future a lot from it. Bad side again, lots of stress for pioneering. We spend a lot of time in the office, a lot of weekends working. Nobody asked us to. We kind of wanted to, but still, like, huge shout out to Zach. He was just killing it. And everybody else laughed him. So that was pretty cool. That was very impressive. And yeah, my delta is that we should do it more often. What's for next? I'm sorry I did not do this, but I'm going to talk for 2 minutes of what we're planning next for the Xamarin. So we wanted to move step by step to see if we are able to deliver the full project with 2 engineers. So that we'll do that in 2 steps. Next project that we will sell to Xamarin is going to be 3 engineers. 1 senior, 2 base level engineers for platform specific purposes. If this project will go well, the next one is going to be 2 senior engineers, and both of them ideally knows Android and iOS, so they're able to work on features, handle one feature on both platforms at the same time. This is a plan. It's far away. I think maybe Q3 or Q3 or Q4 in the next year we'll be able to shoot for this kind of project, but the next one is going to be way more promising. Yeah, so expect more of Xamarin programs. Thank you for the challenge. Questions? Oh, who would have questions?
It's not really a question. This is something I wanted to add, I guess, too. A lot of times, if you're working side by side with somebody else, let's say like myself, Dave, I found like the best thing to do is at the beginning of this sprint, kind of go through what you are working on. And a lot of times, like I'm working on feature A, you know, Dave will be working on feature B, and then like midway point, we'll kind of swap. So that way, like, share code that I wrote for feature A, you can do the UI for that part, and I can do the UI for the other feature. So like, definitely having that communication helps me to move forward, because it's very easy to kind of like tie it up with, you know, who's doing what, or what, who's bringing share code for what, and what's just a little tip that I found.
Did you, or like, so did iOS engineers try to expand Android on iOS with this project, or did you not have time for that?
This. Great question. I was willing to, but we didn't have time at all. We didn't even review each other's code except for view models. Or some like, I know there's a memory handy happening, so I'm like, hey, this is wrong. But Zach learned a lot about iOS, right?
Hi guys. I was really asking for the mic. Anyway, no, but I think one of the major benefits for this was we learned how the other developers work. So I think I really learned first of all, how smart the iOS guys are. But also, there were doubts. No, just kidding. No, you just learn how people work. And I think it definitely opened my eyes to all the stuff iOS has and they don't have, and how it works. And it was great. I think at the beginning of the project was just me and Alex, so we reviewed our code. We reviewed each other's code quite a bit. But then as time went on, I just didn't have time. So I was able to see how things worked. So it was cool.
Yeah, in the support time though, right now there's a planning on asking me start loading Android on Monday, starting next Monday. So there's going to be a plan for the Xamarin department. Is going to be happening. Eventually, the plan is for both engineers. Like there's going to be no iOS or Android engineers in the department. There's going to be mobile engineers, and you'll be expected to know both platforms. Also, it's kind of this thing because we approach that. This is also kind of unavoidable, but yet the mistake we made. We approached writing this project as if we are writing iOS and Android app using Xamarin. What we should have done is write a Xamarin app. Like we should have left the assumption that we should just work as we are used to work and build the thing that we built multiple times just with a different language. Instead, we should have started as like, yeah, we're building a new thing. We have a trade-off. We need to forget everything we know about the tools we have and to start building the new thing. Because there's a reason for why it's not just we were fans and we wanted to do the Xamarin project for no reason. We wanted to see if it's possible, how beneficial it is to share the code. Does it impact the velocity of the project? Does it impact the cost of the support of the project and velocity of development after V1? And very valuable things that you get from sacrificing the way you work traditionally. It's just a matter of like, what do you value more? Do you want to do this shared effective thing, or do you want to deep dive into your native code? It's totally equal parts. It's just like you need to understand it's not just like you're writing as code shittier or Android code with way more pressure. It's still writing a different kind of product, and you're getting different kind of results from it. So it's harder, but you achieve more in terms of efficiency.
Is this a personal thing that you seem to like it a lot, generally speaking, and that maybe doesn't like the rest of the Android engineers? Is it because Microsoft is behind, or is it because you personally just hate the way it works? And also, if you did because they're behind, they're at a time where they're going to catch up on iOS, they're Microsoft. They talk about the future features, and all these new developments are they going to fix some of the negatives? Basically, sure, in the near future, are we going to be able to do work on Xamarin?
So I kind of remember the JP told us that they're working on a hot reload for the emulator for Android right now, which now is not working, but it should be working sometime soon. Obviously, they are working on the IDE to make it support better. But now that I'm thinking after this whole rhetoric, it feels like there might be Android has issues with its own system, and iOS has less issues about that. So it might be on top of the problems that we learned with third-party in itself. There's also issues with Android itself that might be harder to tackle. Or to have fun. This is their only solution how to stay in mobile. They don't have Windows anymore, so this is just the only way they can drag developers there. I didn't know the timeline. I see that they were pushing releases very often, and they were very serious about it. They were very serious about marketing as well, and they're going to be working on it. So I expect also part of the problems. I don't know, Kang may speak more about it, or Zach, but part of the problems can be just solved. Like the issue with libraries can just be solved once by us or by Microsoft. We just have to say, give us libraries. And they're like, fine. Or not. But yeah, you want?
Yeah, I think if you just think of this project, one of the biggest issues is just nothing to do with the technology at all. It's just the timeline was extremely wrong. Like, almost, I mean, honestly, really wrong. Just really no other way to put that. And so we just had no time to figure out anything. Kind of just had to be slapped together, especially on Android. And so that really fit my opinion a lot. So I think if I were to actually do a deep dive, and maybe we had people here fixing the third-party libraries, we had some more time for them to sprint, it would have been nicer, but yeah, it was really tough just to get things done. Sometimes I was here every day, 8:30 every day, and I live on Long Island, so I had to get up at 6, and I was here till 7 most days. So it was just like, it was just so much time, so much effort, and I'm not sure it's there. But if we had more time, maybe, I don't know. But yeah, I think if you were to just think of the project, the tech could work, but the timeline was really hard on us. Yeah.
I have a question for you. Do you think you would be able to deliver the same amount of stuff?
Yes. I think yes, because a lot of the problems we had are solved. You know, like, first of all, Excel player is much easier to use. Native Android billing library is much easier to use than native Android. I wouldn't have to learn dependency injection. I wouldn't have to figure out all this different stuff, you know? Honestly, you could have just used Amex or Pivot, taken the piece from that, slapped it in, done the rest. I think it would have been tough to do by myself, but I don't know. Like, Sheen would have been able to do it in 1 week, and he would have been sleeping the rest of the time. No. So, yeah.
More questions? Right. First ever Xamarin project is delivered. Thank you all very much. You're a wonderful audience. Even you. Good job.